Now we're going to find the root of a transcendental equation. Cosine x equals x. Transcendental equation, it's kind of complicated, but on a very fundamental level, it's not a polynomial equation on a very fundamental level. But anyway, this is a trigonometric equation, but it also involves a variable x, x to the first, polynomial. We want our answer to cosine x equals x to be correct to 6 decimal places. So let's try Newton's method. Well, where are we going to begin this thing? Well, let's start with a sketch of the intersection of y equals the left side of the equation and y equals the right side of the equation. For y equals cosine x, you know we have a typical cosine function, and for y equals x, we have our line passing through the origin at a 45-degree angle from horizontal. So let's put those together. There's our cosine function from 0 to 2 pi anyway. And here's our y equals x. It's called the identity function. And we know that the points on the identity function y equals x all have the same x and y partners, 0, 0, 1, 1, 2, 2. Let's mark the values, the real number values on the x-axis for significant values for the cosine graph. And let's mark some points on the identity function 0, 0, 1, 1. And we can see clearly in this picture that we have an intersection that occurs below the point 1, 1. Below the point 1, 1, because of course the highest the cosine can be, the function is 1. So clearly the intersection is at a value for x that's smaller than 1. I marked that x on the x-axis. So we're going to let our first iteration, x of 1, be equal to that number 1, for which the actual answer will be smaller. And then the cosine of x being equal to x, we'll solve that, get everything on one side to get cosine x minus x equals 0. And we'll call that our function. So f of x equals cosine x minus x. And the derivative of that is negative sine x minus 1. And our first iteration, our first approximation for x will be 1. Therefore, x sub n minus plus 1 is equal to x sub n minus the cosine of x sub n minus x sub n over negative sine x sub n minus 1. And I'll just go ahead and pull out a negative sign and change the negative in front of the parenthesis to a positive, cosine x sub n minus x sub n over sine x sub n minus 1. Now we're going to have to use a calculator to evaluate this, and we're going to have to put it in radian mode. This is very important. Figure out how to get your calculator into radian mode, not degree mode. And then our second iteration, because we already guessed at the first iteration, x sub 1 equals 1. Our second approximation, x sub 2, is equal to 1 minus the cosine of 1 minus 1 over, well, here, I went back to the negatives after I pulled out a positive, negative sine 1 minus 1. Okay, so when we put it through, we get 0.750363887 for our second guess. Our third guess, I'm not going to show the details, gives us 0.739111289. Our fourth guess, 0.739085513. Our fifth guess is 0.739085513. Okay, hold it. We agree to 8 decimal places. They asked us to have a correct answer up to 6 decimal places. We did better than that. We have agreement up to 8 decimal places for the fourth and the fifth estimation, which is really more than we needed. We only needed 6, so we did better than they wanted, and that's good. That's where we will stop. We'll say that x now is approximately equal to, and we'll round our answer to 8 decimal places. 0.739085 is the solution of the equation cosine of x minus x. So you see how useful Newton's approximation is, especially in a day when there were no calculators, there were no computers. It was a pretty sophisticated idea, a way to solve these transcendental equations and other problems.